Elizabeth Colbert, Under a White Sky, The Nature of the Future, narrated by Alex Vincent and Oliver Maines.
In our time on planet Earth, humans have had a massive and undeniable impact. In fact, one so great that some argue we've sparked an entirely new geological era. The Anthropocene. Humans now control the world's major rivers. Our biomass outweighs that of wild mammals 8-1, and we've directly altered half of the ice-free land on our planet. Our species has been incredibly successful, but that success has come at a heavy cost. Atmospheric and oceanic warming, extinction, desertification, and deglaciation. In the past, people spoke of the control of nature. In other words, using technology to solve the problems that nature presented. These solutions, however, created entirely different problems, ones that are now in dire need of solving. These blinks tell their story.
Blink 1 of 7.
Plaquemine Parish in the U.S. state of Louisiana is one of the fastest disappearing places on Earth. Situated at the southeasternmost tip of the state, the parish today consists of little more than 2 skinny strips of land clinging to the tail end of the Mississippi River. Each year, fewer and fewer people remain in Plaquemine, but all of its residents, even teenagers, remember a time when buildings stood on patches of land that are now completely covered by water. Plaquemine is by no means unique. Louisiana's coastline as a whole is rapidly shrinking. Every hour and a half, a football field's worth of land disappears. The responsibility, ironically, lies with the vast system of artificial levees, flood walls, and retaining walls originally created to keep the water at bay.
The key message here is, Louisiana's levee system is causing its coastline to disappear.
Before human intervention, the Mississippi River carried hundreds of millions of tons worth of sediment south every year. Almost every spring, the river flooded, and as a result, sediment poured out onto the surrounding plain. Over time, that sediment built up into what's now the Louisiana coastline. But when French settlers arrived in Louisiana, they built levees, raised ridges, to prevent the river from flooding their cities. The levee system has largely done its job, but it's also responsible for the rapid disappearance of the Louisiana coastline. The Mississippi can no longer dump out its sediment, which means there's no new earth being layered atop the old. Simultaneously, the existing soil, which is soft and watery, is becoming more compact over time. The result? Land shrinkage. Now, people must do the river's job. One ongoing project involves sticking a massive drill bit into the riverbed, kicking up sediment, then sucking it through a pipe. The sediment, nearly 1 million cubic yards of it, is then discharged to create new land areas. This is well and good, but it simply can't be done fast enough to keep up with the rate of land loss. For that, a bigger, bolder solution is necessary. That solution, proposed by Mississippi's Coastal Protection and Restoration Authority, is to punch 8 massive holes through the levees surrounding the Mississippi. This, the CPRA believes, will re-establish the natural sediment deposition process. There's a terrible irony in this, of course, that it's necessary for humans to intervene again so a natural process may resume.
Blink 2 of 7.
The Chicago Sanitary and Ship Canal is a murky river that stretches 160 feet wide. Its role is deeply important, if not glamorous. Before the canal existed, all of Chicago's waste was dumped into the Chicago River. From there, the waste, including human feces, cow and sheep manure, and rotting animal guts, floated down into Lake Michigan. The lake was, and still is, the city's only source of drinking water. After countless typhoid and cholera outbreaks, the Sanitary and Ship Canal finally opened around 1900. The canal literally changed the direction of the Chicago River, making it flow away from Lake Michigan and into the nearby Illinois River instead. That did solve the waste problem, but it caused devastating ecological issues that required another round of interventions.
The key message here is, tinkering with nature can lead to ecological disruption.
The Sanitary and Ship Canal connects Lake Michigan to multiple nearby rivers, all of which were once separate ecosystems. This allows easy travel for humans, ships, and waste, but also fish. This is more significant than you might think. Ecosystems in Lake Michigan and the surrounding rivers are fragile. If a non-native species is allowed to enter them, it can wreak havoc. That's why the U.S. Army Corps of Engineers had to place electric barriers in the canal, designed to keep out certain fish. Today, public enemy number one is an invasive species called Asian carp. Asian carp is a catch-all term for 4 different species of fish. They were brought to the Mississippi River in the 1960s as biological controls, a natural way of controlling the growth of aquatic weeds. The carp's job was to feast on nutrients in the water, but it turned out they were overqualified. Carp have insatiable appetites and feed almost constantly. As a result, the carp ended up outcompeting or overeating native species, greatly disrupting the ecosystem. This means that if even one carp manages to break into Lake Michigan from the Sanitary and Ship Canal, the consequences could be disastrous. The electric barriers have worked so far, but they aren't fail-safe, so additional solutions are necessary. Kevin Irons, who works at the Illinois Department of Natural Resources, had one idea. Carp Fest, an event designed to create a demand for carp. Humans are great at overfishing, Irons thought, so why not take advantage? Just make them want the tens of millions of pounds of carp swimming in the Mississippi, and they'll take care of the rest. Is this the solution? The author has her doubts.
Blink 3 of 7.
In the mid-1800s, a large species of amphibian called the cane toad was brought to the Caribbean. Cane toads are a splotchy brown color, with bodies weighing up to 6 pounds and eyes set with thick ridges that give them a permanently leery expression. The toad's reason for being in the Caribbean was to fight beetle grubs, a species that was destroying regional sugarcane plants. Eventually, the toads were also brought to Australia, where they quickly spread out and made themselves at home. Unfortunately, their presence has been a disaster for the continent's native species. While Australians have devised all sorts of ingenious solutions for trapping and killing the toads, scientists have come up with a different solution: genetically modifying them.
The key message here is, gene editing may restore balance to certain ecosystems.
The major problem with cane toads is that they're toxic. When they're frightened or eaten, the toad's glands release an enzyme called bufatoxin hydrolase. This enzyme mixes with the toad's natural poison and multiplies its potency 100-fold. The poison alone is nauseating, but combined with the bufatoxin hydrolase, it becomes deadly. Enzymes like bufatoxin hydrolase are encoded by genes. This knowledge led scientist Mark Tizard to wonder, could those genes be disabled to create detoxified toads? It turned out the answer was yes. Tizard enlisted the help of another scientist, Caitlin Cooper, who used CRISPR technology to edit out the gene that codes for bufatoxin hydrolase in cane toads. CRISPR encompasses several different techniques, but the basic premise involves cutting out a section of DNA and either disabling it or replacing it with something new. Then it's a question of what to do with the newly detoxified toads, a problem scientists are still working out. One possible solution is to use the detox toads as a sort of training device. Australia has no native toad species, so the animals don't know not to eat them. But if scientists fed animals the detox toads, they'd get sick but not die. Then they'd remember to steer clear of the toads in the future. The idea of gene editing animals feels uncomfortable to many people, but Tizard argues that the environment he and other scientists are working with is already genetically modified by invasive species. Their entire genomes don't belong there. In contrast, gene editing involves altering just small pieces of DNA and ultimately restoring balance to traumatized ecosystems.
Blink 4 of 7.
On the edge of blisteringly hot Death Valley, California, is a cavern known as Devil's Hole. Swimming in it is a species of deep blue inch-long fish called pupfish, specifically Devil's Hole pupfish. The name originates from the male pupfish, who can sometimes be seen wrestling one another in a way that vaguely resembles puppies at play. These tiny fish are also perhaps the rarest fish in the world. They only exist in this unique location. Because of their vulnerable status, biologists make special efforts to ensure that the species can survive.
The key message here is, species like the pupfish depend on human assistance for survival.
4 times a year, a team of biologists from 3 different government agencies travels to Devil's Hole to conduct a pupfish census. In 2006, they counted just 38 pupfish. Since then, the number has slowly grown to over 200. How did the pupfish's numbers dwindle so low in the first place? Well, back in the 1950s and 60s, developers began buying up land near Devil's Hole and pumping water from the aquifer that feeds it. Over time, the pumping greatly reduced the size of a part of Devil's Hole called the shelf, where the pupfish lay their eggs and find food to eat. By 1972, the shelf had shrunk to barely a quarter of its original size. Eventually, the Supreme Court ordered the pumping to cease, and water levels rose again. But they were still much lower than before, causing the food web to remain fragile and unstable. The National Park Service now delivers supplemental meals to Devil's Hole to ensure the pupfish's survival. But this hasn't been the only measure taken to save the pupfish. About a mile from the real Devil's Hole lies a fake version. The 100,000-gallon refuge tank is designed to mimic the cavern in every way except for those that harm the pupfish. When the author visited in 2013, about 50 adult fish lived in the fake cavern. Why do all this for a fish? After all, our planet has seen plenty of extinction events throughout its history. Yet, perhaps, inexplicably, we take issue with being responsible for another species' destruction. So, instead of allowing them to die, we've created an entire class of conservation-reliant animals like the pupfish. After pushing them to the brink of extinction, they can now only survive with our help.
Blink 5 of 7.
The 1980s were a particularly devastating time for Caribbean coral reefs. Thanks to a combination of development, overfishing, and pollution, half of the Caribbean's coral disappeared during this decade alone. The problem, however, wasn't limited to the Caribbean. Climate change was warming the oceans to temperatures many corals couldn't tolerate. In 1988, for instance, a major spike in water temperatures spelled death for more than 15% of corals worldwide. And warming is just one aspect of the problem. Another is the change in ocean chemistry caused by fossil fuel emissions. With all of these issues combined, the world's reefs are in danger of disappearing forever. We may be able to save them with a little help from evolution.
The key message here is, selective breeding could, to an extent, help coral reefs survive.
Ruth Gates was a marine biologist with a particular passion for corals. Though deeply saddened by the destruction of the reefs, Gates had hope that they could be saved. And she had an idea about how to do it. Corals frequently die in what are called bleaching events. When water temperatures rise, corals kick out the tiny plants that live in their cells, which causes the corals to turn white and ultimately die. Gates knew that after a bleaching event, some corals can bounce back by attracting new plants. She wondered if that was due to genetic advantages in certain corals. Could she breed them for those advantages? Gates sadly passed away before she could see her experiments through, but other scientists are now testing out her ideas. They do this by first exposing corals to high levels of stress. Those that survive are taken and selectively crossbred. Their offspring are thrown back into tanks and exposed to even more stress. Over time, this process would enact a kind of assisted evolution. The resulting supercorals could then be used as the parents whose children can repopulate the world's coral reefs. It is unlikely that corals will adapt before the oceans grow too hot, so this might be our only option. Either we help corals evolve at a more rapid pace, or we simply let them die. The latter, of course, isn't actually simple at all. No one knows how many creatures depend on reefs to survive, and consequently may die along with the reefs. But even breeding supercorals may not be enough. What we really need is to get our act together on climate change.
Link 6 of 7.
For the last 10,000 years or so, Earth has had a pocket of remarkably stable climate. Prior to that, rapid climate changes were the norm rather than the exception. But we humans lucked out. The stable climate we entered into allowed us to settle in places permanently, building farms and cities. To do that, we chopped down and burned forests, which released CO2 into the atmosphere. The quantities of CO2 were small but impactful, causing overall atmospheric CO2 levels to remain constant when they should have been falling in accordance with natural cycles. Since then, human influence over emissions, and by extension the climate, has only grown stronger. We may be past the point of simply reducing our emissions, and instead may need to remove them entirely.
The key message here is, carbon removal may be necessary to combat global warming.
The consequences of having higher quantities of CO2 in the atmosphere are deadly, and they'll only get deadlier. Droughts will last longer, storms will rage more fiercely, and heat waves will grow ever more devastating. Scientists have difficulty predicting how hot the world can be allowed to get before we truly hit the point of no return. Officially, it's an increase of 2 degrees Celsius. But staying under that number would involve major changes, revamping agriculture, transforming manufacturing, and scrapping all traditional gas and diesel-powered vehicles. Sounds a bit unrealistic, doesn't it? Carbon removal is a solution that could potentially swing the math in our favor. The idea is to extract large amounts of CO2 from the atmosphere, essentially creating negative emissions. There are lots of ways to do carbon removal. One of them uses rocks, which are one of the Earth's largest reservoirs of CO2. At a power station in Iceland, CO2 is captured rather than allowed to escape into the air. Then, the CO2 is mixed with water, creating a kind of high-pressure club soda. The club soda mixture is injected deep underground, where it reacts with the volcanic rock that exists in Iceland and then mineralizes. Believe it or not, this is a process that would eventually happen without human intervention. All the CO2 we've emitted would eventually return to the Earth and turn to stone. The problem is that that process would take hundreds of thousands of years, and we don't have time to wait for nature.
Blink 7 of 7.
On the evening of April 5, 1815, loud booms resembling cannon fire began to issue ominously from Indonesia's Mount Tambora. 5 days later, lava and a massive column of smoke erupted from the volcano. Thousands of people died almost immediately, but Tambora's killing spree continued for years. When the volcano erupted, it released over 100 million tons of gas and fine particles into the atmosphere. Those particles blocked the sun, resulting in frigid temperatures that caused harvests to fail and potentially millions of people to starve. This was obviously a catastrophe. But what if it could teach us something about how to fight climate change? If volcanoes can lower global temperatures by adding particles into the atmosphere, could we do the same?
The key message here is, solar geoengineering could help cool the Earth, but not without consequences.
Adding particles to the atmosphere to block sunlight is the basic principle behind solar geoengineering. To do it, airplanes would fly up into the stratosphere, the second lowest layer of the atmosphere, and pump it full of reflective particles. Less sunlight would reach the planet, and temperatures would cool. But there's a catch. Solar geoengineering would address the symptoms of climate change, but not the cause: global carbon emissions released through human industry. In a sense, solar geoengineering would actually make us utterly dependent on the particle payloads keeping the planet cool. Eventually, the particles injected into the atmosphere would fall back down. That means we'd have to keep replenishing them. And what if there was an external event, like a war or a pandemic, that caused us to temporarily stop? All the warming that had been diverted would suddenly enter the atmosphere and cause a major, shocking spike in global temperatures. Plus, to keep up with the warming, the payloads would need to grow ever bigger and the flights ever more frequent. And the bigger the payloads, the more likely there'd be strange side effects. An especially remarkable one would be the potential for the appearance of the sky to change. Thanks to the color of the particles, our blue skies could turn white. In spite of all of this, solar engineering has been described by several scientists as inevitable. A world without global warming may actually be one where we gaze up at a white sky rather than a blue one.
You've just listened to our blinks to Under a White Sky by Elizabeth Colbert.
The key message in these blinks is that people have been attempting to control nature for thousands of years. In many cases, we've succeeded, but in doing so, we've created new problems that now threaten countless aspects of life on our planet. Some of these problems can be patched with relatively minor interventions like electric fish barriers and fake caverns. But others demand bigger, more dramatic solutions. Genetic engineering, solar geoengineering, and carbon removal, to name a few. These solutions may feel uncomfortable, dangerous, or disconcerting, but the potential consequences of not implementing them are simply too grave to ignore.